That's working. All right. We'll actually do some calculations on the board here today, so I might actually going to have this be a bigger part of the screen. And once we finish up, just so it captures on the video, I'll like go through and zoom up on stuff so you can go through things. Good, we got Haley's head in there. That'll be really the critical piece of information we need to have in. All right. Okay. So, go ahead and pull up your data set that is your ordered means set. Okay. So what I'm going to do is I'm just going to go, we already looked at this, but I'm just going to go through and cut this down to just the books that we have for information from. Okay, so we've got program. Okay, so for this set, we're going to have 365 folks. Okay, and so I'm going to go through and means 365, that looks good. And I'm going to go through and I'm going to analyze general linear model, speed measures, all this handout we're calling this session. And this session, how many levels? 4. Add that, fine. Look at intake, 2 weeks, 4 weeks, 6 weeks. Got our polynomial contrasts on there just so we have it. Go through, oops, and the program is over between. Lots. Have session on my horizontal axis, different lines for program. Add that and continue. Postdoc, I'm not going to worry about that. Marginal means, if I want to go through and take a look at those, we're going to go through playing with our observed means, but we'll go through, continue there. And then options are descriptives, effect sizes, homogeneity variance stuff. Okay, so we go through, paste that up just so I got it. File going on that. Okay, and so remember, I'm going to switch over to the handout just because see that a little bit better on the screen. But what we found is for this, now remember this is looking at folks who are in an inpatient center receiving some treatment. We've got 3 different groups, group 1, 2, and 3. We don't know what those groups are, but they're just different groups, different treatment groups. And then we're going through and following scores at each assessment point. Okay, and if we go down through, we see that we have very clearly a main effect of session, suggesting that as across these repeated assessments, means are changing somewhere, right? So we don't have the same mean value across repeated assessment, but that main effect of session is modified by program, meaning that the treatment program that people are in changes in some way that pattern of means across repeated assessments, okay? Let me see, we have some decent evidence for that there. Any questions about sort of what these effects mean conceptually? Comfortable with this?
Say that one more. So what is the p-value is that there's change across the sessions?
Yeah, what is difficult, and I'm trying to be precise in my language, is because these repeated measures ANOVAs, they're not looking at a like linear change or any change. They're not looking at change at all. They're just looking at different levels across repeated assessments. Now, if I was to run this in like a latent growth model, then I could talk about group impacts the trajectory of treatment response across over the course of intervention. But that's a different model looking at latent change across, right? Continuous change. This is just looking at levels, right? So if I were to go through a latent growth model, would be an appropriate analysis to run with our vignette data, because there is no growth trajectory to that. It's just different levels, right? So in some ways, these repeated measures ANOVAs are a flexible approach, because it doesn't. Things don't need to necessarily have like some temporal relation to one another. But because of that, we need to just be careful how we're talking about them here. So what I'm saying is, what this is saying very literally is that the pattern of means across repeated assessments changes based on program. Okay, so we just have, it's essentially a moderation. Okay, here we're thinking about program as the moderator of this pattern of means across repeated assessments. And this is why for like these types of analyses, I like line graphs that are kind of following that change. You kind of have those connectors. You could do it as bar graphs, but then it's kind of weird for me to kind of see and understand what's going on. Versus like a tween subjects ANOVA, like a factorial ANOVA, they're bar graph because I've got discrete groups that are independent of one another. Here we've got dependencies, and so that's why I will typically graph these out as line graphs. Is just easier to see.
So even though it's like significant, potentially the p-value is
Yeah.
Raising a question. We don't know like where the difference is. Like it could be the same between groups on 1, 2, and 3, but very different at time 4.
Exactly. It could be anywhere there, right? And it's really hard to know exactly what the big thing is driving stuff. And this is where sort of that investigation process, the difference that I'm seeing that I test for, that I'm going to sort of put interpretive value into, may not be the same thing that Jalen identifies as the thing. She may go through and take a look at this bag. Fine, Kate, but I really think the reason that this is popping as an interaction is because of this other thing. You need to go through and look at that. Okay. And so we'll go through and take a look, and we'll see this. If we go down through where we talked about our test that we see between subjects effects, again, here we're saying that collapsing across repeated assessments, do we see differences in these overall in these programs? And here we don't have something that would meet sort of benchmarks for making strong conclusion that these are different. Now, in this case, I don't know that this effect means much to me, right? Because basically I'm saying, if I just take everybody in treatment 1, treatment 2, treatment 3, and I just look at their average depression score across the whole time that they're in here, am I seeing differences? Well, if I'm not, I don't know. That's a weird thing. Like average depression score across the whole period of treatment it's not a construct that has a lot of value to me. Now, if you had sort of 3 treatments, 2 that absolutely didn't work, they just kind of flatlined, and then another group where you had a strong reduction, maybe you would see something here. But even that's not sort of really all that interesting. It's just saying that overall, are there differences? So for this problem, I mean, I would want to go through, take a look at this, think about it. Is there anything there? What does this mean? But at the end of the day, there's not anything really there that's worth exploring or thinking about too much, just from a conceptual standpoint. Okay. But if we go back up and we take a look and think about sort of this within subjects contrast, right? For your main effective session, you've got a linear effect and a quadratic. Cubic, I don't know that there's anything useful to think about there, but because we do have ordered means, now these are kind of interpretable. We go down through, now we've got an interaction, and that kind of screws up a straightforward interpretation of those. But again, this just want to point out that it really depends on the problem and what's going on in terms of what parts of your output are going to be relevant or interesting. Okay. So if we go down through and we take a look, okay. And here, if we're looking at Levine's, right, at baseline, things are fine. At 2 weeks, things are fine. At 4 weeks, maybe some differences. Again, we've got a really massive sample. By the time we hit with 6 weeks, we've got some differences there. But again, this is something I want to be thinking about. But given what I'm looking at, this kind of makes some sense, right? By the time we get to the end of treatment, some people are going to be in different places than other people. I wouldn't necessarily not expect differences across these. So that doesn't mean it's not problematic, but at least I'm sort of understanding why things are coming up as they're coming up with stuff. And so down we go through, take a look at so I guess here, if we go back through and take a look at our interpretation. We're saying evaluation of a 3x4 mixed factor ANOVA with repeated assessments on the final factor, strong support for group by session interaction. Results suggest that reductions in depression over the course of intervention differ by treatment group. Here, is there anything about sort of this interaction that says that there are reductions going on? No, but I've got eyeballs in my head and I can look at it and say, we're getting reductions. That's what's happening in these things. And so just saying, basically what we're seeing is reductions. What we just don't know is how those reductions are differing across different groups. Okay. People comfortable with the interpretation of the omnibus effect, kind of what's happening in there. Okay. Now what we need to do then is we need to think about how am I going to go through and tackle this? Okay. Any thoughts in terms of looking at this pattern of means? What might we do to go through and start to chase this down, try and see what's happening with stuff? What starts to become important or might be important in terms of trying to figure out where these are differing? Any thoughts or ideas? Yeah, how do I tackle this? Right, so we're interested in whether or not we're seeing basically group level effects on treatment response. Okay, and our interaction is saying that, yeah, pattern of means across repeated assessments isn't the same across these groups, right? What differences might people be interested in exploring?
But follow the order of they're ordered differently at each session. So like the red is always higher than the blue and the green.
Okay.
Places at session 2.
Okay, so that's something that maybe I could look at if I was interested in a session by session. So like, how quickly is this working, right? Which may be a reasonable thing to ask. What I might look at is, do I see differences at each one of these time points, right? And I can go through and do that. Now, if I go through and take a look, the thing that I want to be thinking about here is there are at each one of these time points, I've got 1, 2, 3, I've got 3 different pairwise comparisons that I could go through and make, right? So if I'm sticking myself to 3 pairwise comparisons, I've got 3, 6, 9, 12, right? So I've got 12 pairwise at say here, there you go. Okay, so I've got 12 comparisons that I could make there, right? Now I could also go through and start, if like 2 of these are kind of like comparison groups and one of them is an actual treatment group, then maybe I've got different contrasts, right? I want to do sort of these 2 against this one each time or something like sort of. So this isn't the only way you can go through and do things if I have more specific hypotheses, okay? So maybe I could go through and take a look at each one of those, right, to see if there are differences there. Okay. What else could I do? Gave you, sound like you had an idea. What else might I be interested in looking at?
Maybe there's a difference between if session 3 and session 4 are different from each other, or if session 2 is different from session 3 and 4. I don't know.
Yeah,
It's
no,
like some contrast.
absolutely. I could go through, and if I had specific hypotheses, I could go through and look at within session stuff, right? So for each individual group, I've got 1, 2, 3, 4, 5, 6. I've got 6 pairwise within group comparisons, right? So I've got 6 within per group. It's gonna give me 18 possible within group comparisons, right? Allison, did you have something else that you were thinking with this?
I was just gonna say like mean differences, like. I think so, like one, like between the first and fourth, that be like kind of mean difference.
Yeah,
And then
between
compare those.
session 1 and and so why might that be interesting, session 1 and session 4? What are we getting at that, or sort of time 1 and time 4?
Like intake and then like final.
Pre-post stuff, right? So, I mean, that's captured in this right here, but maybe that's more what I'm interested in. Yeah, Kate, did you have something else?
Well, you mentioned that you might be writing on the board a lot today and
Yes.
the video is flipped, so it might be really hard to.
I think
Oh,
it still shows that.
Yeah.
It should
Normal, yeah.
normal.
Okay,
I think
I'm just
so.
worried about being able to read it right backwards.
yeah, right, I guess we'll zoom in and then you just have to put a mirror like in, so like sort of
That works.
get a secret decoder and, okay, so yeah. Basically, if I'm sort of wanting to go through and look at pairwise, there are 30 different pairwise comparisons that I could pull out of that. Do I want to spend 30 tests, correct, for 30 tests to go through and do this? Absolutely not, right? And so what we want to do is think about like, what is important? What do I care about? How do I go through and start teasing this apart to start thinking about what about this interaction really matters to me for the most part? Now here, I don't know, right? But maybe there's a specific hypothesis where I'm interested in the contrast between 2 and 3 and 2 and 4, or 1 and 2, or something along those lines. But for our field, it's actually not super interesting. I mean, I'm not saying that it's not, it's just, there are reasons it might be, but for this, maybe, like Allison's saying, I just would like pre-post, like what are we seeing in terms of change? Are we seeing noticeable differences in change pre to post for these different groups? Okay. And if I'm randomizing people to groups, which one of these between group comparisons might I be interested in? One, yeah, because if I've gone through and randomized people, like, I don't know, those dots aren't all on top of one another. Are they different enough for me to say like, oh yeah, people started in different places? And then maybe I want to compare these last ones too, right? Do people end at different places? This is all starting to get at different ways of understanding change, right? I can talk about change in terms of where people start and where people end, but I can also talk about it as sort of within a group, how much of a reduction that we're going through and saying. And so if I'm going to go through and try and think about like how I want to go through and tease this apart, I got to be strategic, right? Now, do I necessarily need to waste formal p-values and tests on whether or not we have pre to post treatment differences given the size of our sample? And so the magnitude of, no, that's dumb, right? Like, I mean, I can do it certainly, but it's going to be an infinitely small p-value. That's, I don't know, like statistical tests aren't the end all be all. Like, back, oh, is that statistically different? Back, I don't know, use your head. Do you know anything? Like, what do you think is going to go on? So I know what I'm going to do for this is I'm going to go through And I'm gonna go through and I'm gonna run. I'm gonna run pre-post differences for each group. But I'm not gonna include those in sort of my overall tests. I don't need to run a test on that. I can see that they're different, right? Like is a jug of milk and your pickup truck different? Like, yeah, I don't need to see if they're different things, right? I can just know that. But what I might do is in SPSS is just run those through as paired samples T's, because what that's gonna give me, it's gonna give me the point estimate of the difference. It's gonna give me a confidence bound around that. I'm gonna give an effect size for that. There's information that's useful in terms of talking about the magnitude of reduction that we're seeing across each one of those. But that's pretty obvious. I don't need to run a test on that, right? But maybe I didn't have a priori, ahead of time, I didn't have, predictions about whether or not, I'm hoping if I randomize people to group, hopefully that's not different. But also at the end, I don't know, it's just kind of exploratory running these, right? So what I'm gonna do here is I'm gonna plan for, and because I've looked at them and wondered, like, hey, I wonder if these are different. I've already ran those in my head, right? So I'm just gonna go through and I'm gonna say at time 1 and time 2, I've got 6 pairwise contrasts. Okay. So want to think about, and I want to have some corrections for this because I just kind of eyeballed this, like, oh, hey, I wonder if these are different, right? Couple of different ways I could go through and do this. I could think about like using a modified Tukey with this to say like, oh, can I kind of apply a Tukey correction to correct for 6 tests here, right? I mean, if I go through, I could Bonferroni this or Dunn-Sidek, right? And if I did that, I'm going to get an alpha equal to 0.009. Is that right? Yeah. Okay. Basically, I take 0.05 and divide it by 6. This is what I'm going to get, right?
What's the alpha?
You take alpha, so 0.05 divided by the number of tests that you got, right? That's your Bonferroni. Dunn-Sidek is a little bit different, but it's going to be close, right? But that's pretty severe, right? And the thing is, remember the Bonferroni, Dunn-Sidek, these are not post hoc comparisons. There's 4 to control for specific tests, not just test the hell out of anything. They're going to be too stringent, right? If I look at a modified Tukey, I can say, well, I want to look at 6 comparisons, right? And if I said R equal to 4, right? If I set R equal to 4, that's sort of hitting pairwise comparisons, right? And that's going to be 4 times 3 over 2. So if I set R equal to 4, that's actually going to give me correct for the right number of comparisons that I want to. So I could do that. If I go through and I look at across my groups, I could say, I can set degrees of freedom to 222. If I go through and I look at, because remember what we want to do for, if we're using modified Tukey, we have to set a degrees of freedom to go through and test this. What I would be doing here is saying, what's the smallest, what are the comparison of my 2 smallest groups here, right? If I go through and take a look, this is going to be my a comparison of groups 2 and 3, right? Group 2 has 101 people, group 3 has 123. If I sort of add those and subtract 2, I get 222, right? I'm going to have comparisons in there with more degrees of freedom, but if I have to set it for the whole thing, I'll probably go conservative, right? And again, remember that this is, if I'm modifying, if I'm bending Tukey to my will, I'm just screwing around with stuff. I'm just trying to think about like, hey, how can I get something that's kind of close, okay? So if I do this and I go through and look at a critical Q, my Q critical for R equals 4 and 222 degrees of freedom is going to be 3.67, right? And I know that T is equal to Q divided by square root of 2, right? And so if I take that 2 key, that critical 2 key for this, I can turn that into a T critical. 2.60. So if I wanted to, and I wanted to take this approach, what I could do is I could say, well, what I'm just gonna do is I'm just gonna run a bunch of t-tests. And then I'm gonna look at my critical value. If it's less than or if it's more than 2.60, I'm gonna claim that as being something that's interpretable based on my 2 correction. If it falls below that, even doesn't matter what the p-value is, I'm gonna say, well, it falls below my critical value, so it's not interpretable at based on my corrected value. Yeah, Johnny.
How did you get that T critical again?
I just took my critical Q that I pulled from my 2 key and divided by the square root of 2. That Q distribution and T distribution are directly related to one another, right? And so if I wanted to do this, I could just go through and then run all of my pairwise comparisons and then just look at them, and any of those T statistics that exceed 2.62, I need to say, hey, I've gone through and done this, and here's what's going on, right? And if it falls below, I'm like, well, we don't have evidence for differences here. You kind of follow the logic, remembering sort of how we can sort of fool around with 2 key. And this actually works out nice because I can set R to correct for the exact number of tests that I want to correct for. And so we're in an okay spot. This won't always happen. Yeah.
A little lost on R.
Remember, the R in 2 key is the number of comparisons or the number of means. Here, I'm just trying to find an R that corrects for 6, right? So if I set R equal to 2, then I just have 1 comparison. If I set R equal to 3, right, then I have 3 comparisons, 4, 6. And so this has nothing to do, like, again, I'm not using 2 key properly, right? Like I need a hammer and I grab a wrench and start beating on stuff here, but it works kind of, okay? Other questions about this? Johnny?
When you take the R and multiply by 3 and divide it by 2,
Yeah,
where are those 2 numbers coming from?
this is just to get for R, the number of comparisons. This is just simple math to go through and calculate the number of pairwise comparisons. It's going to be the we'll call it P, the number of groups that you have, times P minus 1 over 2. Okay. So if I have 3 groups, that's 3 times 2 is 6, divided by 2 is 3. 4 times 3 divided by 2 is 6. If I have 5 groups, right? It's just a slick and easy way to go through and tell how many pairwise comparisons, unique pairwise comparisons can I run with this set of means. Other questions? Why might we not want to do this? Yeah, I can do this, and there may be reasons to do this. I've done this before and published things, but what you really got to do is you got to sort of explain to people what you're doing and why you're doing it in a way that makes it seem credible, and so that people go through and be, okay, I can see what you're doing. Fair enough, I'll give that to you, right? And so, I don't know, certainly kind of in this case kind of works out well, but it's not a precise correction, right? Because different comparisons are going to have different degrees of freedom. I just set mine to the lowest of the possible comparisons that I can have. I'm kind of jimmying around with this, right? And so it's not perfect, right? I mean, it's something that's better than nothing, but it's not perfect. And then I have to explain it to somebody, right? Other thoughts on what we might do with this? That Benjamin-Hochberg procedure we talked about. That's kind of nice, right? Because then I can just go through and have an adaptive criteria for however many tests I want to do. I don't have to do so much jimmying around with stuff, right? And so for this approach, what we're going to do for this example, I wanted to walk you through kind of what this would look like. We're going to say, so it seems like a lot to explain. I'm just going to use Benjamin-Hochberg and sort of set things up in that fashion. So that's what we're gonna do. But any questions about sort of this? Mess with stuff. Doesn't like that, I guess.
I just unshare for a second.
What's that?
You could probably just like unshare your screen.
Okay, that's a smart thing to do. All right. Hopefully that's not all backwards on the.
You can
It
flip
will
them.
be.
It will be. You can flip your camera in your settings though.
We can screenshot it and flip it.
Yeah.
It's not flip, because I watch your videos.
So,
Yeah,
I've
we're
watched your
usually on
videos
Matt's, so you're on yours this time.
okay, well, we'll do the best with what we've got.
Can I take a picture of it real quick?
What's that?
Can I take a picture of it
Yeah,
real
take
quick?
a picture, whatever you want to. Do you want me to stand up there with it?
You want to?
Please, will you
Thumbs
send it
up.
in the group? Yeah, that's exactly what I was gonna do.
Thank you.
Genius. Alright.
Okay, so now I'm not sharing my screen, so I wanna share my screen. Okay, we're back in business. Okay. So. Just to make this a little bit more efficient, we'll go through and work from the, work from our, handout here. So what I did to do this, I just went through and split file by group. And then just ran a paired sample t-test, looking pre-post differences. Okay, people see that, and it's something we've done a whole bunch. And so what I'm gonna get is, I'm gonna get for program 1. I'm going to, and I don't care about the p-value, because I already know the p-value is gonna be wicked small, so like, I'm not even focused on that, right? What I wanna go through and do is take a look though at my confidence bounds and sort of my mean difference. So here I've got evidence for program 1. I'm seeing an average of about 15.4 unit reduction on the BDI upper and lower bounds here. Okay. And then if I go through and I request an effect size estimate. Now, this is the thing that we need to be careful of and trying to think about, like, what's happening. Like here, what SPSS has given me is looking at the square root of the average variances as your metric. Are we happy with this, or do we have a better option maybe for this?
When you're asking it, we probably have a better method.
Well, it kind of depends, right? So again, what this has gone through and it's done is it's looking at variability at time 1, variability at time 2, taking the average of those variances and then taking the square root of it, right? So just make sure when you're doing this that you're selecting an approach that makes conceptual sense. Now, if I was just going through and I was just wanting to look at a measure of effect size for pre-post change, what might be a better metric? I mean, this is the square root of the average variances. This is essentially just like pooled variance estimate. We just don't need to pool it because there's the same number of people at sort of pre-post, right? But what might be a more interesting standardizer in this case?
Hedges G.
Well, this is kind of what Hedges G, this is what Hedges G is. This is essentially calculating Hedges G for within subjects, because we've got variability at time 1, variability at time 2. Just take the average of the variances and take the square root. So that's kind of what we're getting already. Now it talks about Hedges correction. This is for small samples. We've got like 100 and some people in here. We don't need to worry about that, right? Yeah, Mandy.
I think this might be wrong, but
Did we talk about like glasses?
Yeah, glasses, I mean, because we've got a strong baseline, right? What I could do is I could just take this mean difference of 15.383 and I can just divide it by the standard deviation at baseline. And that gives me a glasses delta. And now that's a variance component that means something to me. I can say we've gotten sort of an X unit standard deviation change relative to variability at baseline, the relative to variability where people are coming in, you know. This is an okay thing that I think that would be a nice way to go through and plan this. Now, with the way I've set this up, one of the things that I don't think you can get here, I don't think it will give you glasses delta for a paired sample test. And here, if I use the standard deviation of the different or the square root of the average variances, I can get an upper and lower bound on that point estimate, which here kind of I like because I can talk about like worst case scenario, like low bound population estimates supported by these data in terms of effect size is still over a standard deviation change. So just because I like this, I'm going to go through and select this, but a glasses delta, if I were just reporting a point estimate, that would be a perfectly good way to go through and do things. The other option here is going to be the standard deviation or sort of using the standard deviation of difference scores as your standardizer. That's the one we need to be careful about, right? Because remember we had talked about I can have wild variability at time 1, wild variability at time 2, but very small variability in my change. What we can sometimes end up with is a wildly inflated effect size with that. So you just need to be careful with your within subject stuff, particularly make sure that you're being thoughtful about this. Okay. Questions about what we're doing here. And again, I'm not wasting statistical tests because I don't care because I already know it's going to be sort of massively small. You had a T statistic of 15. Like this is it's not like, oh, do we have evidence of a reduction? Yeah, we do. I just wanted to get those auxiliary statistics out of this to go through and I can report so I can start to flesh out a reasonable interpretation. Yeah, Johnny.
Can you just help me understand why Hedges G would not be the most ideal? I think I'm getting mixed up.
Are you worried about Hedges G here or just in Hedges G in general?
Like calculating Hedges G for this like trouble.
Yeah, but are you talking about like Hedges G that we've talked about or the Hedges G, like Hedges correction, like this, the thing on the page?
The Hedges G that we've talked about.
Okay, that's what we're doing essentially,
Okay.
right? Now, if I'm running a between, and when we talk about Hedges G, we generally talk about as a in a between subjects design, right? So I've got 30 people in this group and 40 people in this group. I want to sort of run my independent sample t-test and I want to use a pooled variance, something like we would call a Hedges G, right? Yeah. But here, because it's just all the same people that we measure time 1 and time 2, we don't have to pool anything. I mean, that's essentially what it's doing. Like if you were to run variance at time 1 and variance at time 2 and run it through your pooled formula, you just get the average of the two variances because it's the same number of people there. So that's essentially what we're doing. Now, again, this is a thing, and I've talked with several of you, like it's hard, it's sometimes notation is confusing. So SPSS is calling this Cohen's D. And if you do look at between subject stuff, it'll still call it Cohen's D, which is fine. They're all kind of D statistics, right? It's just not, it's ambiguous in terms of what this is. So if you go down and take a look back, oh, well, what we've done in the between, and we'll get there. In the between subjects case, it'll say Cohen's D, which is actually what we've talked about as Hedges G, because it's a pooled estimate. And then they've got Hedges correction, and then Hedges unbiased G that we had talked about with the small sample stuff. So it's just a lot of things that you kind of have to keep in mind. I wish everybody was on the same page if there was like a statistics police and said, this is what we're going to call everything and keep it the same, but it's not, right? So you just need to be kind of aware and sort of think about like, okay, what's happening with this stuff. But functionally, for your purposes, the stuff that we've done, that's Hedges G is exactly what we kind of did here. Okay. Yeah, Allison.
And you said that glasses delta is the mean difference divided by standard deviation at baseline.
Standard deviation baseline. And here we have a true baseline, and that's kind of a nice way to go through and look at stuff. And so, but for this demonstration, I really kind of want it. I mean, I could go through and calculate that glasses delta if I wanted to. We just take that and divide by standard deviation baseline, and then you got it.
Well, then how do you get the confidence interval for that? Or you can't?
It won't give it to you. right? Or it's not an option in SPSS, and so, Stata will give it to you. I'm not sure how they derive it necessarily. But it's not an option in here, so just for the sake of convenience, this is fine, this is fine. I mean, it's basically hedges G, which people like is a reasonable default. If I wanted to attach a specific interpretation, delta, I think would be a little bit more meaningful, but this isn't terrible, right? So just in your work, I just want you to think it through and sort of being intentional in terms of your choices for your standardizer. Someone else have a question?
I was gonna ask the exact same.
Okay. Okay, so this is what we've got for first group. Program 2, same thing. Here we've got a reduction of close to 20 points, right? With our lower and upper bound, we've got a point estimate of over 1.5 standard deviation decrease, right? So impressive stuff for program 2. And then for program 3, here again, we've got a 20-point change, upper and lower bound in terms of data supported population estimates. Our point estimate for our change here is a full 2 standard deviation reduction, right? My lower bound estimate for this is 1.7 standard deviation reduction, right? I mean, like, so, and you'll see when I started going through and putting this together, you're just seeing such incredible change. Just wanted to say, like, hey, even on the low end, most conservative estimate, we still got massive changes here. Here's the point estimate, but even if you look at the low bound, it's still like huge, right? So we know that we're getting substantial reductions across all of these, okay? What I then did with this, okay? So for me, I'm trying to think about like, oh, like how can I understand change? Like, so we're seeing huge reductions for all of these. What I did, remember that ESCI sheet that I sent you last semester? That's pretty slick way to go through and just plot in point estimates and confidence bounds. I just put together a couple of quick graphs just for me to help me try and understand like what's going on here. Here we've got point estimates and confidence bounds for my mean differences, right? So overall just raw change, right? And so if I'm looking at this here, I'm saying that I got my little legend down here. 5 corresponds to program 2, 6 corresponds to program 3. So in terms of just overall raw change, I'm getting these groups 2 and 3 are about the same in terms of what I can expect in terms of overall reductions in symptoms here. Program 1 is still big, but there's maybe, it looks like these 2 are outperforming these 2. Remember, if we go back through, talk about that coming in bitch article that we talked about last semester, interpreting differences in confidence bounds based on percentage overlap. It looks like this program 3 is for sure demonstrating greater reductions, at least in absolute terms from study from program 1. 2 and 1, maybe, and then maybe a little bit closer. But it looks like here, that it looks like maybe programs 2 and 3 are outperforming program 1 if we're looking at things in terms of just raw reduction. And this is just giving me a visual way to kind of go through and look at it, as opposed to trying to sort of in my head put the numbers and see what's happening. We're gonna get what I was doing with this. Okay, and then here, same thing, but this time with my effect sizes, right? Here we're seeing again, program 3 very clearly outperforming program 2 in terms of effect sizes, right? Or program 3 and program 1. Program 2 kind of is as an in-between here, right? So it looks like we kind of have consistent with whether we're talking about raw difference in change or standardized effects. We're seeing kind of a step, so we got 1, 2, 3 going on with this. And people kind of see, so what we did here, and again, none of this has to do with tests or p-values. I'm just kind of looking at just estimates with this.
Did you make that in Excel or is that from SPSS?
This is in Excel. Yeah,
Okay.
this is what that
I've never gotten that.
No, this is me leaving SPSS in the dust and getting creative with the science art, right? The mean stuff. So, all right. People kind of see, and this is just sort of me trying to build a case in terms of how do I understand this. All right. So. Other thing we can do here, now we want to go through and take a look at, and again, always having your figure there next to you to look at and reference is really going to help you sort of keep sort of track of what we're up to. Remember that we wanted to go through and take a look at stuff at time one and or at intake and discharge to see if we have differences. Okay. Now, what I've done is because I said, well, I just went through and pairwise comparison to everything in my head anyway. So what I'm going to do is I'm just going to go through and run my sort of pairwise tests. Another thing that you could do if you had multiple of these, you could say, well, I want to run a one-way ANOVA here. If I was going to go through and test differences across all of these, I might change things up a little bit. I might run one-way ANOVA, one-way ANOVA, one-way ANOVA, one-way ANOVA. See if there's anything that you can fool around with to start with. Okay. And if I don't, if my one-way between doesn't come up as sort of telling me differences, cool, write that off. Looks like those are comparable. Looks like these are comparable. Then these are the ones I went through and found, right? I mean, you're adding in another omnibus test, but you're arguably sort of cutting down. So then you need to go through and report a bunch of pairwise tests on this other stuff. Now, with the approach that we took, I said, well, doing here, 6 tests. I'm going to Benjamin Hodgberg that. And so we're going to go through and just run those. But it's just a different approach, right? That you could do. And then I often will do. Do we have differences? Do we have difference? And in that case, just running that one-way ANOVA is just more of a way to just like rule out, do I need to screw around with this? Or can I just say nothing to see here? This is probably not where the interaction is happening. Let's move on. Yeah.
If you were to run a one-way ANOVA and it doesn't like show evidence of a difference, does that like get factored into like any correction you would do?
This is where the horseshoe stuff comes in. Like you have to go through and say, do I correct for that test? But this is the same thing that always comes into omnibus tests, right? I can run the omnibus tests as a way to save running tests, but I'm running a test to save running tests. And do I ever just hit an omnibus test back? Yep, there's differences in there and just stop, right? And so there's kind of a philosophical kind of debate going on. And this is where I can't tell you, like, this is the way to go through and do how to approach all situations, right? You have to go through and think about like, okay, with this approach, what's going on? What are the critical tests that I would go through it and take a look at? Other questions? Okay, but this is pretty easy. Here, we're just looking at between group differences for this variable and this variable. It's not anything different than what you've done before. So here, we're just running, and down here you can see, I'm just running t-tests. I'm looking at 1 and 2, 1 and 3, 2 and 3. I just had SPSS give this to me, and so I'm doing this at intake and discharge. That's all I'm doing here, right? So here we've got looking at 1 and 2 at intake and 6 weeks. Okay, and so we are just getting our T statistics and our P values, because remember, we're going to Benjamin and Hochberg this stuff, right? So I'm just getting T tests, P values. So it looks like maybe at intake, we've got some differences. So here, if I look at my Levine's test is not saying that we have evidence for differences in likely differences in variability between groups 1 and 2 at intake or at discharge at 6 weeks. So here I'm saying my T, my two-sided P, T, two-sided P, maybe looks like there are some differences at intake, but not at follow-up, right? Down here, I'm requesting effect sizes. Now this, Johnny, is where we go through, we got Cohen's D. This is what we would normally talk about in here as Hedges G. It's just looking at the pooled variance. Here, we've got Hedges correction. That's just unbiased G, right? Here, it is giving us Glasses delta for the between. It won't do this for the within, but it will for the between, right? And this is just looking at variability at baseline. You just need to make sure that, look at what the standardizer is and make sure that that corresponds to, because here, looks like my Glasses delta, my standardizer 13.08. It looks like that corresponds to the, oh yeah. So here, it looks like it pulled the standard deviation for group 2. Do we have, is class delta a good metric for these between group comparisons? No, why not, Johnny?
We don't have a baseline.
Yeah, there's no real baseline. I don't know, it's based on the way we've set this up. I don't know that there's a good control comparison here, right? But just keep an eye on stuff. So probably just Cohen's D, or what we call hedges D, just looking at the pooled variance across these is gonna be our best bet, okay? So here are comparisons for 1 and 2, comparisons for 1 and 3 at intake and discharge. For 2 and 3, intake and discharge, these are just tests that you're gone through and run, right? And so then what we'll do is finish up with our Benjamin Hochberg, right? Remember that for this, what we're doing is we're taking the comparisons that we've run and we're just ordering them in ascending order by probably p-value, because it's a difference around where we go through, put these in order from largest p-value to smallest p-value. And then we have our Benjamin Hochberg P that we're going through and taking a look. And then I've just layered into this table S base factor. Here's the actual sort of comparison that I've got, right? The mean difference. Here's the confidence bound around that. There's my hedges G, confidence bound around that. It just kind of go through and kind of keep track of what exactly is happening with this stuff. And if we go through and we take a look, we see that, so at 6 weeks, at post, we're seeing a difference between 2 and 3, right? And if we go back up and take a look, groups, 3 is our lowest, right? So we're seeing that 3 has a smaller score than 2. And that we're also seeing that 3 has a smaller score than 1. Both cases, we're seeing about a 3-point reduction, or 3-point lower scores for group 3 as opposed to group 1. Confidence bounds, effect sizes are nearly identical here. Okay, so even though at intake we did see sort of a at least if we're looking at things at per comparison rates, a difference between 1 and 2. We got a p-value 0.0175. Our Benjamin Hochberg is 0.0167, so we didn't quite meet threshold for our corrected stuff. So we would say, well, maybe there's a difference, but sort of didn't sort of correct, so or didn't hit, so we're not going to spend too much time with that. Okay. So then we've got stuff here. Okay, so did people see how we ran sort of Benjamin Hochberg stuff here? Okay. So now the task is to go through and pull this stuff together. We found that the pattern of means across repeated assessments differed across my 2 groups, right? Or across my 3 groups. How are they differing? I don't know, right? What it looks like is we found substantial reductions for all groups. If we're talking about within subject stuff, it looks like maybe an advantage in terms of absolute difference for programs 2 and 3 relative to 1, right? If we're looking at standardized effects, 3 very clearly outperforming 1, 2's kind of in the middle. So we're seeing maybe some differences in terms of how much reduction we're seeing across these groups. And then if we look at our between comparisons, we're seeing that program 3, these folks are finishing with the lowest scores relative to the other 2. Right. But it's just us kind of trying to think about like sort of how do we go through and think about sort of this change and kind of tying it together. Okay. So if I go through and talk about, so this may be a way that I might start to integrate things here, right? So we're saying follow-up tests and depression scores from intake to 6 weeks looked at separately within each treatment. Okay, so we're talking about our within group stuff. Additional exploratory analyses conducted to assess differences across both programs, both at intake and 6-week assessment. Alpha inflation for exploratory stuff managed through Benjamin. Then we're saying, okay, we're gonna go through start with within first, right? We're seeing significant reductions in depression for program 1, 2, and 3 with all our information, right? We're seeing big reductions, okay? Point estimates of average change in BDI and corresponding effect sizes, along with relevant confidence bounds presented here. Evaluation of these data suggests potential enhanced treatment response in 2 and 3 relative to changes in program 1. Specifically, patients program 3 report average reduction of 20 points. Population estimates ranging from X to X. Program 1, by contrast, 15-point reduction here and here. Reductions in program 2 comparable to those in program 3. Interval estimates within subject effect suggest similar pattern, although important to note the lower bound estimates supported by these data, full standard deviation reduction across all programs, right? So it isn't me trying to say like, hey, this is kind of what we've got going on. Maybe a slight improvement in sort of this program relative to the other two. This is kind of what that looks like, but overall, huge reductions for everybody. And here, this is one of these situations where I think talking about those interval estimates is kind of cool. Because basically, if they say, hey, 4 people in this program, here's what we saw for this group of individuals, my data would support reductions ranging anywhere from this to this. So if I'm a clinical researcher or sort of a patient or anybody, like, hey, how much should I expect to reduce? Well, maybe on average, anywhere from this to this, right? Maybe some more, maybe less. Kind of a cool situation. Okay. Now we get down to say exploratory analysis of between subjects differences at intake in 6 weeks, consistent with potentially greater responding in program 3. Group level contrast failed to provide strong support for differences of initial depression after we adjust for multiple comparisons, right? I'm not saying that there wasn't, but once we adjust for them, it's not sort of clear evidence that we had support for differences. Average 6-week assessment, individuals in program 3 evidence lower BDI scores relative to program 1 and program 2. All of our sort of information that says like this is kind of what's going on. Comparisons, depression scores in patient program 3, nearly 3 points lower than comparison programs. Whereas lower bound estimates for population differences were minimal. Confidence intervals supported within confidence intervals for within subjects comparisons continue to suggest potential advantage of programs 2 and 3. Okay. Overall results offer support for differences in effectiveness, as noted. Great reductions in within subjects effects 4, 3, and 2 as compared to 1. Between groups, some incremental benefit of program 3. Results of the current project provide greatest support for enhanced treatment response in 3 as compared to 1, with promising but less compelling evidence for increased efficacy in program 2. Okay. So a lot of stuff to go through and manage and sort of keep together with these analyses. This is just one of an infinite number of ways that we could go through and pull this thing apart. What I'm saying is, for me, I really don't care necessarily what's happening at 2 weeks or 4 weeks. There's stuff that we could look at and explore and try and pull apart. But I don't know what I would say about it, even if I did find differences. Now, if I am a process person and wanting to see like at what point, or sort of like if I'm starting to become interested in like how quickly things are dropping, maybe I get in the weeds with that. But just because I have a data point and a comparison to make doesn't mean I have to bite on it, right? I get to go through and think about like, is this sort of under something that sort of helps tell my story, helps interpret what's happening with this stuff. And you know, you get a reviewer that's like, well, you didn't look at this, or you didn't look at this, and you don't look at this. But yeah, that's sure, that's true. You can point to things, right? But what I've done is I've given you means and standard deviations. I've given you all the information that you would need. So it's sort of strong work towards open access stuff. Here's the data. Like, I don't know, like go nuts. It's a free country. Like, look at whatever you want to look at. This just isn't important to what sort of I'm wanting to look at, right? What I wanted to do, because we know that our repeated subjects designs with those repeated assessment, that adds to power, and it sort of kind of goes through and helps me kind of take a look. So I wanted to have those in there, but I don't necessarily need to go through and run all possible comparisons, right? So it's taking a step back, looking at these interactions, saying, okay, what did I find? And then now what's my game plan? What makes sense for me to go through, tease this apart, to go through and say, now is pre-post differences and group level differences at time one at intake and discharge, is that the only place where we might see differences across this? Nope. Are there other points in this where we could see things starting to sort of drive that interaction term that popped? Absolutely. But me chasing everything down isn't necessarily going to clarify things. It's just going to give me more to talk about, right? And so just a big conceptual piece to sort of thinking about how do I go through and tackle stuff. Questions here? So thinking about this, and this is for you clinical folks, do I necessarily care about a 3-point difference at discharge that some people have a BDI score 3 points less than other people? Kate doesn't think so. Why not?
About the measure itself and a 3-point difference wouldn't be very
Yeah.
large difference.
Yeah. So just practically speaking, a 3-point difference on this measure is probably not something that I'm like, I would not strongly advocate for, but program 3 is the way to go, because in this sample at the end, they happen to be 3 points lower than the other folks, right? Here, probably I'm looking more at that within a group change, and it looks like, well, we are seeing pretty sizable increase in the overall effect in program 3 relative to program 1. And so where people start and where they end is maybe less important to me than thinking about how much they reduce within that group, right? So I would probably put more interpretive weight on that within subjects stuff, like where they're going and how much of an observed difference that we're seeing than between, but people like between group differences and things like that. But even if those things hadn't turned out to be different at the end, I don't know that I'd necessarily care about that stuff so much, because this doesn't matter so much as like how much people are falling, right? Now, if that group ended up, you know, way lower than everybody else and also ended up way lower at the end, like then that starts to be like, well, I don't know that I care about that, because they started lower and ended lower. They just sort of an overall sort of intercept thing that shifts as a basic shift down, right? So it's just sort of thinking about what am I looking at? What are my numbers telling me? And then how do I pull this all together in sort of some sort of reasonable interpretation? All right, questions? Okay, cool. Let's go through, take a break. And then when we get back, okay, so let's come back at 3:30. When we come back, we'll tackle our between groups comparison. Within group is nice because it kind of like it gives you a little bit more of a handle on what to look at, because there's just a natural ordering of things. With our data that doesn't have a meaningful order, things get a little bit more tricky, because who knows, right? And the way I go through and order things is going to change what the shape of that data looks like. There's not any other way I can order that data that makes sense. With our vignette data, depending on what I plug in as first, second, third, fourth, it's going to change the whole shape. So you have to take a look at it. Okay, see you all in about 10.
No.
You know how to run these. I guess. Than SPSS.
You don't, I have to see you asking.
The exact same.
Yeah, it's the exact same thing that we've done before, so.
I don't know.
It is.
Yes, unfortunately, is you're really smart, sorry.
Okay. So. We got that back up. Okay. Nothing we did here is exciting or new or anything that we haven't done previously in past things. So, we're just loading up sort of our dropping sort of things into our SPSS menu, and you have step-by-step instructions on sort of where things are going in the handout. So no one should be worse for the wear that did not sort of catch where SPSS stuff was going in. So I'm gonna hit OK. All right. All right, I'm gonna go through and pull up the mixed effects here for our beliefs ratings, just because it'll be easier to see. Okay, so yep, see all this right there? All that is exactly what you need to be doing with stuff. So you set up, you're in good shape. Okay. All right, and so remember, as we went down through and looked at these here, remember that on our omnibus test, we found an effective rating. Okay. Daniela, what does this tell me that I have an effective rating here? Mean effective rating in these data.
Okay, is for this one, is rating like they're rating how willing they are to be their friend?
Yeah, it's the vignette rating. So we've got 4 different trauma vignettes here.
Okay, so this is the interpersonal, the negatives, the
Yeah,
other ones?
yeah.
So like the rating that they had on people that have experienced trauma has a significant effect on if they got either
Okay.
side, yes?
Yep, and that's gonna be the interaction
Okay.
piece of things. What about just the main effective rating here? What is that telling us?
That affects if they would, is this about support? I forgot what this one is.
Yeah, so the willingness to provide friendship,
Okay.
yeah. So basically what we're saying here is that across these 4 different vignettes, willingness to provide friendship, collapsing across a group, it just differs, right? So basically, people's willingness to provide friendship is dependent on the vignette. It just changes across the vignette, right? So if we've got a car accident, combat, assault, and natural disaster, it just kind of changes on people's willingness to provide friendship, right? So it's just saying that they're not the same. Okay? But then we get down and we also see that we have some evidence here, not terribly strong evidence, but it's sort of there was something we would definitely say is worth talking about, where we have a class by rating interaction. This is where we're saying is the specific response to these individual vignettes across these repeated vignettes is dependent, at least in some way, on kind of this negative, benevolent, or interpersonal sort of group, right? So basically, where I'm at starts to change things a little bit. Okay? And so we went down through and we take a look at our tests of our within subjects contrast. Do these make any sense in these data? Nope, right? Because as soon as I start to scramble what order I put these vignettes in, and these vignettes are counterbalanced, right? As soon as I start to change the order around, it's going to give me different numbers in here. This, for these data, the tests of within subjects contrast mean nothing. There's nothing interpretable about these. So we can we often ignore these and don't spend much time on them, but for here, they're nonsensical. There's nothing to talk about with this, okay? Now here, if I go through and I'm going to start thinking about this, if I'm looking at my Levine's test, it looks like for each one of these vignettes, I'm seeing what looks like pretty clear evidence of differences across these. Now, I've got a pretty big sample, so these are pretty sensitive tests, but it looks like the variability in how people respond to these are kind of different across each one of these vignettes. So again, when we're thinking about like that old school approach where I'm just going to go through and start pulling error terms from my overall ANOVA because I've run a perfect design and I'm just going to capitalize on the full analyses, should I be even considering that for these data? No. If you remember, we screen these data, they're weird, they're skewed. I've got uneven group sizes. I've got violations of homogeneity of variance across the board. There's nothing that I should be confident that just pulling an error term from an overall ANOVA and slapping it into this stuff is going to be useful, right? So again, this is where Howell would make a recommendation. It's just, all right, now we're just going to fall back on paired sample tests and contrasts and things along those lines, right? As opposed to trying to conduct something. And this is different because again, and this starts to become relevant with the Bateman article, we've got observed groups as opposed to manipulated groups, which also adds in sort of different uncertainties and things along those lines. So here, like this design is a big old mess, right? So we want to be careful in terms of how we're going through and approaching things. If I go down through and here, now this, if I go through and I just take a look at my test of between subjects effects, Allison, what is this telling me here?
That across like the different points or the average of the points that like there's a difference between the classes.
Right? Now, before with the depression problem, was this effect of interest? We didn't find anything, but it wasn't really interesting. Is it interesting here? Yeah, maybe, right? Because if I look at the average willingness to provide friendship across these different vignettes, I can think about that as just like overall willingness to provide help to people who've had some bad stuff happen. And if I'm saying collapsing across vignettes, if I'm looking at the average rating across these vignettes, and I'm seeing differences across my groups, I don't know, it's kind of like sort of irrespective of what we're talking about. It looks like we're seeing group level differences in overall willingness to provide support, which is kind of interesting, right? Now, this twin group effect is modified by the within, right? So like you can't sort of put too much interpretation here because this effect is involved in interaction. But interesting, at least noteworthy, I would say, as we're going through and thinking about things. Okay. So if we go down through and we take a look at what this effect looked like, boy, right? Lindsay, what are we seeing? I don't know. What are you kind of seeing in terms of just eyeballing this? What might be going on in terms of this interaction effect?
It looks like negative, has like a pretty steep decrease the second time point.
And what do people remember what that second effect was? This is my combat folks, right? So it looks like we're getting a pretty substantial reduction there. So certainly just eyeballing things, it looks like there's a pretty big difference there. Like that would be, and this is the thing, like remember that if I'm talking about interaction, I'm getting a different shape and profile, right? Like overall, it looks like my negative group is just sort of basically, it's just a basic shift lower than these other ones, right? But that doesn't necessarily indicate an interaction. What it looks like is this interaction is happening kind of right here for this one vignette. Overall pattern is looking, so it's just super exaggerated right here, right? So thinking about that, sort of trying to take things into account as I'm considering how I want to go through and tackle this in terms of follow-up stuff. Okay. So, and if we go through and click back over and take a look at our omnibus interpretation here, right? We're saying results of a 3x4 mixed factor ANOVA model with repeated assessments on the final factor, modest evidence for a class by rating interaction, the within by between subjects effect, and these data suggest that differences in willingness to maintain friendship, hypothetical survivors of trauma and non-traumatic events, well, it's not non-traumatic events, it's traumatic events, may depend on pre-existing beliefs regarding the impact of trauma. Matt, can you shoot me an email to fix this? With this one, we're not sort of having non-traumatic events. Yeah. Thanks. Okay, so people comfortable with the overall interpretation of this. Okay, so what we want to do now is how do we go through and tackle this? So again, here, if I'm looking at this, starting to think about how many different ways could I break this down if we're just restricting it to pairwise comparisons. I've got three groups, so I've got three different pairwise comparisons that I could make at each one of these. So I've got 1, 2, 3, 4, right? So I've got 3 between 4 each vignette, right? So that's 3, 6, 9, 12. That's 12 differences here, right? And then within group, if I wanted to compare all possible responses to vignettes, I've got 1, 2, 3, 4, 5, 6, right? So I've got 6. Then per class, which again gives me 18. So again, we're back to 30 possible comparisons that could be done within this.
Yes.
Right? So again, a lot of different possible pairwise comparisons that we could go through. Is anybody interested in trying to account for why all 30 of these is going to be interesting or meaningful? I don't want to do that. Seems like a mess. Okay. So again, here, what we might want to do is think about, like, what are our a priori hypotheses? How does this go through? And how do we go through and tackle this? So let's say, just for the sake of argument, that I had to start out with, I said that my a priori hypothesis is that combat ratings for combat is going to be less than MBA salt faster. Okay. And I said, like, boy, I'm just doing some military stuff. I'm just saying that there's something about military services. People are just gonna rate willingness to provide support lower than the combination of these other ones. So that's what I expected, right? And I'm probably seeing that I probably have some evidence for that, right? But what I want to do is I'm going to test the comparison error rates, because this is what I had expected, right? But in terms of exploratory, yes. Here I'm going to say, I'm expecting, because I just looked at it. I'm like, well, I think that overall negative is going to rate lower than benevolent, interpersonal, or each vignette. Okay. And I've sort of run this after I go through and take a look at stuff, right? And so what I'm going to do is I'm going to say, well, I've looked at this after my visual inspection. And so what I did really with those between, I really ran 12 comparisons there in my brain very quickly. I looked at that and I was like, oh yeah, I know I bet negative is less than those other two across the board, right? Well, I didn't just think that up. Like, what I did is I ran it all and said, yeah, I think there's a pretty good chance there. So if I'm being honest with myself, I've got 12 comparisons that I need to correct for, because I went through and ran those real fast in my brain, right? And so in this case, if I go through, I think about a modified 2 key, right? If I set R equals to 5, how many comparisons is that going to correct for? Okay, yeah. Set R equal to 6, what's that going to correct for? 15, right? So I've got 12 that I want to compare for. This is too little, that's too much. So I got to kind of think about, like, oh, what do I want to do? I want to be conservative. And so I'm going to set R equal to 6. Okay. I could maybe set R to 5 and then set alpha 0.01 or something like that, but I don't know. I'm just going to go ahead and be conservative here. Okay. My degrees of freedom. I'm going to set that equal to 127. Okay. That's going to correspond to the degrees of freedom associated with the lowest degree of freedom contrast, negative at 44, and interpersonal at 85. It's the lowest degree of freedom contrast here, so just setting that equal to that. And then if I go through and I look at my Q, that's gonna give me a Q critical equal to 4.10. If I turn that into my T critical by dividing by the square root of 2, then we give me a T critical of 2.9. Okay. So what I'm gonna do is I'm gonna run comparisons, and if they're below that, then I can go through and claim evidence for. If they're not, then they say they didn't meet threshold. Okay. Now, what I'm doing here is a very conservative, like I'm being like super honest with this, right? Because what I'm saying is I went through and like visually on that between group comparison, I just went through and ran 12 comparisons. And then decided after I looked at it what I wanted to do. What I really did is like ran 12 pairwise comparisons. And so I'm giving myself a decent penalty with this. This is pretty conservative and it's not exact. But I'm saying like, well, I just want to, if I fail to identify a difference, it's probably not a critical thing that's going to impact public health at all, right? So I just, we're being overly conservative just so that, you know, I don't, so that people can't criticize me for like sort of having my thumb on the scale for stuff. Okay. People see how we kind of arrived at sort of this kind of about issue here. Okay, now just think about this though, is like what I did is I implemented a pretty severe penalty on myself. What is with 127 degrees of freedom? What's my critical T going to be very close to with that many degrees of freedom? What is it? It's going to be pretty close to 1.96, right? I mean, it's going to get close to Z. Instead of 1.96 for my critical value, it's 2.9. That's a pretty substantial penalty, right? For not knowing what I was up to ahead of time, and I'm not sure why I didn't anticipate maybe the negative group was scoring lower than the rest of them, but in this hypothetical example, that's kind of what we did. Okay. Questions about this? Okay. Yeah, what's up, Minnie?
So you said like with that many degrees of freedom, and then you mentioned like how that will impact like our T critical being close to like 1.96. Like, what exactly like does that mean for us?
Well, it means that the test statistic that I have to get for a comparison for the claim sort of that this is something we're talking about is got to cross a much higher threshold than it would if I were just running things at per comparison rates. Okay. Okay. All right, so questions about what we did here in terms of like putting together a game plan for stuff. Right. I'm going to go through and write a whole bunch of other stuff on there and erase this. Does someone want to take a picture of this? What's that?
She's worried about getting a camera.
They have to move this.
You see that? My.
Okay. So here's what we're gonna do. We go through and set this up. Again, we don't need to run through this in SPSS. You already know how to do it. What I'm gonna start with is my test of my within subjects comparisons. Remember, so my a priori I'm expecting combat to be lower ratings than the combination of each one of these others vignettes for each group. Okay. So what I'm going to do is I'm going to separate my file by class and break things up by group. And then what I'm going to do is I'm going to run a one-way repeated measures ANOVA for each one of those separately, right? So I'm just going to run a one-way repeated measures ANOVA comparing MBA, combat, assault, and disaster separately within each group, okay? And so if I do that, I first get my output from my negative group. Okay, and so I've only got 44 people in my negative group, but here are my means for mean friendship rating in my negative group for car accident, combat, assault, and disaster. Okay, and if I go through and here, I'm not even like sort of caring too much about looking about this piece of things necessarily, because what I want to do is I've a priori already sort of planned these contrasts out. So I'm not paying too much attention to this. I don't care too much. I'm just running this so I can get the information that I need to run my contrasts, right? But I am seeing that, yes, for my negative group, I am seeing differences. Okay. But this table is gonna give me the information that I need to go through and actually run my contrast that I'm wanting to run here. So first thing I'm gonna do, I need to calculate the value of my contrast, right, for this group, okay? And so if I'm comparing my accident group, or my accident vignette, my assault vignette, my disaster vignette with my combat vignette, what are my weights that I need to assign to these 4 conditions?
So you wanna do all 3 compared to
Yep.
just one.
So,
Yeah,
yeah,
1/3, well, let me see here. Put it in the right order at least here. So I've got 1/3, combat is 1, then I got 1/3 and 1/3. Right. And now I think my combat group is gonna be lower, so I'm gonna put a negative there. And now I've got my contrasts set up for my contrast weights. So I'm gonna shorthand this. I'm gonna go 1/3 times 748 plus 7.39 plus 7.39 minus 6.73. Okay, people see how I got that?
Yeah.
Comfortable with that piece, okay? And if I run this out, it gives me a value of my contrast 0.690. Okay. And because I have a standard set here, what I'm saying is that for my negative group, people are literally rating this about 0.7 of a point lower in terms of overall friendship ratings relative to the combination of my other vignettes. Comfortable with that, seeing how we sort of pick that up?
Just real quick, would you get 7.4?
7.48. Oh,
Yeah,
it's 4.
Is the wrong?
Oh, yeah, it's 4.8 on the one uploaded, but up there it's.
I think this
4.6.
is a different output here.
Did it screw? Oh, this is benevolent. Okay. That's
Okay.
that's where that went. Okay, how about
Then,
this?
never mind, I know where it came from at least, I just.
No, let me go through and negative, there we go. Sorry about that.
Okay.
Okay, there we go.
Right.
No, that's right. They should threw you off. You didn't of getting it. Okay. This makes sense. Okay, awesome. All right. So here, value of our contrast, and then I'm going to go through and I'm going to calculate my T statistic here is just going to be value of my contrast 0.690 over square root of 1/3 squared plus 1/3 squared plus 1/3 squared plus 1 squared. Okay, that's just the sum of my weighted or the sum of my weights times 1.634. Where did I get that from? Where do you get 1.634?
error.
Okay, it's my greenhouse geyser error, it's my mean squared error, right? Mean squared just means variance, it's my error variance right down there, so plug that in, okay? And this formula is, I'm not just making this up off the top of my head, it was in previous slide, right? Over 44, this is the number of my sample here, so I do that and I get a T of 3.10 associated with P equals 0.003. Okay. And I run S is equal to 9. Phase factor is 22.70. Okay. So then just ran my test, right? So I do have evidence that yes, indeed, for this for my negative group, I am seeing evidence consistent with my hypotheses that people are rating that combat vignette lower as compared to the combination of the other folks. Okay. So I know here that my T critical for 73 degrees of freedom. That's right. Of this, can someone go through and sort of pull up, take a look and see what is the degrees of freedom, critical T degrees of freedom for, oh, there it is. Okay, got it. Okay. What I did in terms of looking at my degrees of freedom for my greenhouse geyser correction is 73. So T critical for 73 degrees of freedom is equal to 1.993. Okay. So here, if I want to look at my 95% confidence interval, this is going to be equal to 6.690 plus or minus oh, my standard error, got it. Okay. It's gonna be 0.223, 1.9. And here, my standard error is gonna be. At this point, I'm gonna stop doubting myself. I'm pretty sure I did it right. Oh, yeah, that's this piece down here. Okay. I keep looking at this, I'm like, you screwed it up, like, I always doubting myself, I feel like past Josh was always trying to screw future Josh over by making him look like a clown. But here, okay, so in terms of like thinking where this stuff is going, right, so here, we've got our T statistics, we've got our value of our contrast divided by, this is our standard error for this, right? And so here we get my T statistic P value, but if I take sort of this denominator, it's my standard error, it's going to come out to 0.223. Okay, you'll see that. Okay, so if I do that, I get a confidence bound of 0.25 to 1.13, right? So this is a confidence bound around the value of my contrast here, right? So what I'm saying here is that in these data, I'm seeing about a 0.7 unit reduction in overall friendship ratings with data supported values would be anywhere from a quarter of a point to a little over a point reduction here. Last thing I can do is I want to calculate an effect size. So I'm gonna want to calculate average variance. So across this, I can do average because it's all within, so I can just go through and stack these up, right? So if I go through and I look at my standard deviation, I square that, right? So I've got 1.023 squared plus 1.730 squared plus 1.46 squared, 1.039 squared, all of the 4. Gives me an average variance of 1.608. Take the square root of that. Its average standard deviation is going to be 1.268. Okay. Then if I go D 0.690 divided by 1.268, and they give me a D of 0.5. Okay. So nothing that we did here is crazy or new or different than anything that we've done before. It's just kind of working out the math in terms of how do we go through and run this specific within subjects contrast, right? So here, big things to think about, right? So here we've got our test statistics that we've calculated here, okay? Here, I've got my confidence bound. Here, I've got an effect size, right? And so I'm feeling pretty good about being able to describe not only statistical evidence for an effect, but also being able to talk to magnitude, population, or data support population estimates, things along these lines. Okay. We'll see how we went through and did that. Any questions on where I'm pulling information from, anything along those lines? Yeah. Awesome.
I think this is just because I was trying to do this before and I was running into issues. I like never got that same like standard error. Like I know you said it came from like the denominator thing. I could never like match my number to yours. So I don't know if that is where it came from.
Okay, so I would go through and take a look. The one thing, make sure it's not rounding error stuff. Okay, so.
This is kind of what I was asking you in your office, but I
Okay. So let me see, if I take 1/3 and I square that, multiply that by 3, then 1, add that, 1.634, multiply. Yeah, I'm getting 0.223 for that. Did you get it right now?
I'm doing it still.
Okay, and so I'm using the HP sort of with the reverse Polish notation here, everything's contained in.
So should that work if I were to do it as just like remember I told you I was trying to do it with just the paired, like should it match like the output for the paired team?
Well, the sort of the issue is what we would need to do with that is you would need to in SPSS, you would need to go through and take the average of these.
Okay.
The average score across those, but then even that's going to be a little bit different because here what we've done is we've pulling this from your overall ANOVA table, which is sort of looking at these differently, and so it's not going to be exactly the same. So here what we're doing is just splitting our file, running one-way ANOVA individually, and then sort of doing this by hand. Like you used to have to do this by hand for everything. Now for the clean stuff, SPSS will kind of do it for you. But if you went back, talked to people 6 years ago, like we were doing this for everything all the time. And so SPSS will do some things for us better now, but we still have to kind of pick up. But the nice thing here is remember all that sort of nastiness that we had in terms of violation of homogeneity variance and things along those lines. Here we're just running around in a one way for this one group. We lose some power because we're just looking at this one thing, but I'll take that as an acceptable penalty for the fact that my design's kind of all over the board. Questions?
I have a simple question. What
Yeah.
does the BFB number says 22.?
22.7.
Oh, that's 7.
Yeah, it doesn't look like a 7, but I can only get so low, right? I was hitting the bottom of the page there. All right, other questions? All right, someone want to take a picture of that?
Yeah. They don't wanna.
I guess what you could do is like take a screenshot of the thing and then just like sort of put it in their words, flip it around, right? It's a magic mirror.
You don't even have to put it in Word, you can do that on your phone nowadays.
Oh, yeah? Nice. I don't know, I like to work through Word. All right, so basically we can go through this same process for benevolent and our interpersonal groups, okay? We won't go through and work through each one of these. How about this? If you go through and run this and want to do the same stuff for these individual ones, and you want to know if your numbers come up correct, just come see me and I'll tell you what I calculated out for this. We won't do this because it would just be a lot of you watching me do the same thing over and over again. But if you just want to go through and practice doing this, let me know and I'll tell you what we got for those individual ones. Then it'll come up in when we get to the end piece too. Okay, so this covers our within stuff. Now we need to think about like how we're going to go through and address comparisons or between group comparisons, right? Remember that we had said, all right, what we're going to do is I'm going to give myself a penalty, but what I'm going to do is I want to test whether or not my negative group is lower than the combination of my other two groups for each one of the vignettes that we've gone through and ran. Okay. So again, this is going to be a little bit easier because what we're going to do then is we're going to let SPSS do the work. Okay. Here it's nice because I've just got 3 groups. My comparison is I'm expecting my negative group to be different than the combination of the other 2 groups. So I can just set I can just run this in just as a one-way series of one-way ANOVAs, right? So I turn my split file off and then I'm just running a one-way ANOVA for each one of these by class, setting up my contrasts, -1, 0.5, 0.5. Contrasts my negative group versus the combination of my other 2 groups. Going through and run this, and then SPSS just spits this out for me, right? So here in terms of my descriptives, I'm getting descriptive statistics for all of my differences here. Okay. And then if I'm looking at my outcomes here, I got these are my homogeneity variance tests for each one of my one-way ANOVAs, right? So I've got violations across most of these vignettes, so I know I need to be careful in thinking about that. As I go down through and take a look at my results of my one-way ANOVA, right? I'm seeing for my that's my homogeneity variance test. That's not fine enough. Okay, so for just my one-way ANOVA, for my ratings for motor vehicle accident survivors, given my seeing differences across my groups for motor vehicle accident survivors?
Across or yeah.
Or for my motor vehicle accident? Nope, no differences there, right? So I don't need to worry about anything. So I mean, SPSS is gonna give me stuff, but I don't have to worry about it because I ran that ANOVA and I'm not seeing group level differences there, so I don't need to worry about it. For combat, yep, I am. Assault, nope. Friendship or disaster, nope. And so really, the only thing that in terms of these between subject contrasts that I really need to work on is just focus on this. Now SPSS is gonna dump it all out to me because I asked it to, but I don't have to go through and talk about that because in my write-up, I'm just gonna say, sort of one-way, ANOVAs at each, for each vignette. Only identify potential differences for the combat, everything else is done. So I don't have to go like grind out, contrasts for each one of these, right? But if I go down through and I take a look at my output, right here, my contrasts for car accidents, assault, disaster, I can ignore those. Only thing that I need to be thinking about here is my combat. If I go up and see, do I assume equal variances for my combat group? Absolutely not. So the same differences there. So I'm going to go down to this. I'm looking at does not assume equal variances. Okay. And I see I have a p-value of 0.008, a test statistic of 2.65. Okay. Here's my lower bound. Here's my upper bound. And if I go down through and take a look at my coefficient for my effect size for combat, again, I'm using the pooled standard deviation of groups across involved in the contrast. It's essentially a Hedges G here, right? I get my point estimate and my effect size there and my confidence bound for that. Okay. Now, what's the one thing that I need to be mindful of in terms of as I'm moving forward with my interpretations? What did I set as my critical T? Do I remember? .9, right? And my T statistic for my contrast that I did find is 2.77, right? Equal variance, it's above, it's so what I've got is I've kind of fallen into this weird sort of situation where, boy, what do I do with this, right? Because ahead of time, well, I know what I need to do with this because if I set the rules, then I got to follow the rules I set. I can't sort of like, hey, these are the rules, except for I don't like the outcome, and then I go back through and change them, right? We're kind of a weird, ambiguous situation here where I went through and I set with this modified 2P a critical T of 2.9, which is kind of an overcorrection for what I've done, right? And if I didn't violate homogeneity variance assumptions, I'd be cool, but I did, so it's sort of kind of this right here in between piece of things, right? So this is the weird gray space that we exist in, right? So probably what I wouldn't say is that like, oh, nothing to see here. But I might say, hey, in terms of my follow-up, my exploratory tests found what looks like very clear reduction in willingness to provide friendship for combat relative to the other two, for my negative group relative to my combination of my other two. However, we applied a pretty stringent correction to this, and we didn't quite meet threshold. So we're not going to make a strong, draw strong conclusions on this. There might be differences. This might be something to look at, but future research should probably explore this further. Okay. So again, sort of getting us off of, like, I'm not going to make a big deal about this. I'm not going to spend a lot of time talking about it because I didn't meet the threshold that I sort of set for myself. But sort of what I'm saying is explicitly the same thing that we should say for any time we find a null effect is I don't know. There might be an effect, there might not be an effect. I didn't hit quite to what I would want to. Looks like it's kind of trending. Maybe this isn't shut the door on this, but I can't get too much into it because we didn't sort of meet the threshold that I was said that we were going to do with this. Okay, so if we go back through and take a look at what we did here, a very different strategy with this than what we had done before, right? Is here There's lots of different things that we could go through and take a look. We're saying that like, hey, we expected combat to be rated, friendship for combat survivors to be rated lower than the combination of these other two. So that's what I called my shot ahead of time. Then I got this grouping factor, gonna go through to see if it makes a difference. Got a very clear interaction, and if I look at that picture, looks like I've got something pretty substantial going on. What's the only caveat to that? Got a pretty substantial, it looks like I got a pretty substantial effect here, right? Why? What's that?
Scale.
Yeah, because I've zoomed way the hell in on this, right? If I were to go through and look at this at the full 0 to 8 rating, that's not gonna look as prominent, right? So I need to be kind of careful in terms of sort of what I'm looking at and how I would display this in sort of a publication or something like that, right? So, and if I zoom out on this, it's not gonna be sort of as dramatic, but again, in trying to tie all this together, right? You know, I might say small, but you've got the slide, I guess. So here we're saying our operator contrast used to compare self-reported willingness to maintain friendship with hypothetical combat survivors relative to aggregate ratings for survivors of motor vehicle accident, sexual assault, natural disaster, differences in willing to maintain friendship in negative versus combination of benevolent and personal files examined for each vignette in a series of exploratory analyses, modified Tukey used to control evaluation post hoc comparisons. Then I threw up a little sort of footnote there to go through and say like, hey, this is what I did, right? So I wanted people to know what's happening. So we're saying within group comparisons offer compelling support for reductions in willingness to maintain friendship for survivors of trauma versus non-trauma groups. Okay. This is the wrong thing. I got the wrong side of it. This is talking about like sort of going through and taking a look at, I got a, Matt, can you shoot me an email and sort of fix this slide? Basically, this is talking about the difference between a different analysis where we had trauma and non-trauma vignettes in here. But in general, structure would be kind of the same. What we would say is like, hey, looking at these individual groups, what we're seeing is differences in supporting. Okay, it's a mixed match of God knows what I did here. Okay. They're saying observed differences, greatest for participants in the negative, so ignore the top part. Negative profile with data supporting reductions in the larger population ranging from 0.25 to 1.22 groups. Right, participants in benevolent negative profiles also demonstrated incremental reductions in reporting willingness to maintain support, but these are modest with lower bound estimates corresponding to population differences and indicating the possibility of trivial effects. Basically, when we went through and looked at those between contrasts for my benevolent interpersonal group, they came up, but they're really minor, right? Again, speaking to the power of these within subjects designs, right? I was seeing so that dip that we saw for the other two was almost identical. And it calculated as something that, yeah, that we have evidence for reductions, but from a practical standpoint, some pretty minor stuff. Okay. So then we say exploratory analysis between subject contrast indicated comparable ratings of willingness to provide willingness to maintain friendship for negative versus benevolent interpersonal, for accidents and sexual assault survivors and natural disasters. And just this is just p-values for the overall ANOVA. We're saying we're just looks pretty similar. We don't have clear evidence of differences. By contrast, willingness to maintain friendship with hypothetical survivors of combat trauma, about 3/4 of a point lower in the negative relative combined groups, right? And then we have sort of information there. Observed differences exceeded conventional benchmarks for medium effect. the data indicating this 0.65 standard deviation decrease in willingness to maintain friendship. So here, I guess I decided to ignore the fact that we're kind of at an ambiguous situation because we didn't meet the modified 2 key thing. I'll go through and fix that, but that's kind of, again, within stuff, between stuff, kind of going through and talking about things. So here, this is where we're kind of pulling it all together, right? Saying results suggest that both beliefs about the consequences of trauma exposure and the type of exposure event influence willingness to maintain friendship with hypothetical survivors. Individual profiles, all evidence reductions in support for combat versus non-combat trauma. Effects particularly pronounced in respondents holding negative pejorative beliefs about the consequences of exposure. Right? Everybody's saying like sort of less interested in helping out the person who's a military person. It's just particularly pronounced in the negative group, right? Data failed to provide evidence for differences in ratings across negative versus the combination of benevolent and interpersonal, except with relation to hypothetical combat survivors. Again, sort of been thrown through the stuff saying basically impact of beliefs on willingness to maintain friendship may have the greatest effect for survivors of military trauma. So we're just kind of pulling this together to say, okay, it looks like things are different, but really where they tend to be different tends to be so this combat, hypothetical combat group, right? And so our general beliefs about sort of trauma and impact really mostly impacts sort of this one specific type of event. So we're saying, yeah, sure, a combination of profile and trauma type in terms of willingness to provide friendship, but it really is kind of this one group that tends to be driving sort of most of this stuff that we're seeing. Okay. So it's a lot of stuff to try and keep in your head, right? And so this is where you want to avoid just falling back on, hey, I'm just going to run tests to run tests, because then I got a whole page worth of tests that I got to try and figure out, like, how do I put this together? What does this mean? What do I say? Like for these types of analyses, particularly, and we've worked on this all year about sort of at the end, you know, like in implications or what does this mean? Or like, cool, but what next? Type of thing starts to become really important, because with these more complicated analyses, you don't want your results to just be like, and then this, and then this, and then this, and then this is different than this, without sort of tying it together, think about like, what does this actually mean? What does this tell us about our phenomena of interest? All right, questions on sort of the approach, what we're doing, how we're sort of starting to think about grappling with these designs. Feeling okay? Okay. Again, I wish I could come up with a design and say, hey, here are the steps. Like if you follow this decision tree, you will always arrive at the right answer. Problem is there isn't a right answer. There's lots of different ways you can pull apart any of these and start talking about these. It really depends on your research question and what you want to do, which makes it kind of hard, right? T-test is like T-test to T-test, correlation to correlation. As we start to get into these more complex analyses, there's a lot of different ways to go through and pull things apart and understand. So one, you need to have a good idea of how you want to tackle this. But then two, when you're reading this research, know that there are other questions that could be asked and other ways to go through and think about things. And it's fully okay if you disagree with the way an author has gone through and done stuff. If it looks pretty sketchy, like, oh, you conveniently just like these were the ones that you decided to take a look at. That's cute, because there was nothing in your introduction that said that that's what you were interested in, right? So we want to be careful and not just capitalize on sort of the random stuff that's going on, right? So just want to make sure, have a good conceptual sense of what's happening, just make you much better at critically evaluating your research and others as well. All right, questions? You've got it. You've got it under control. This is awesome. I'm very excited for all of you. Okay. All right. Go through, shut this stuff down. And let's finish up talking about some ANCOVA stuff. Yeah. Yeah. What's up? Or we can get you goddamn ANCOVA today. Do it next week. Yes, I always got the goddamn like an extension on this like minor assignment today and then complain about how busy you are and all you do is stats over the weekend later on, like. Please turn it in when you, that's what I told you, right? So here. No groaning, no moaning. And toughen up, jump into ANCOVA, and then we're gonna be in a great spot for next week. I can tell you're excited about my vision, my plan.
It's a sign.
You know, it's because we're doing so much. We're so excited for all things. Good.
Green? Yeah.
I guess this. Microsoft just suggested that I get help. Okay.
Microsoft thinks you should stop today.
This. All right. Okay. This is gonna be quick. This is gonna be easy. What we're gonna do is just kind of go a quick overview of what we're talking about with some of our ANCOVA designs. Okay. This is actually some of my favorite stuff to talk about just because we tend to do this wrong in terms of pretending that ANCOVA does something that it doesn't. Okay. If we think about historically what we're doing in terms of ANCOVA, and so experimental folks, this is something that sort of came out of your tradition in terms of trying to go through and improve the power of your tests, right? When we're running an ANCOVA, what we're doing is we're looking at group differences on some sort of group mean adjusted for a covariate, okay? And if we code these properly, our covariates can be any type of combination of categorical continuous variables that we can go through and throw in this model, okay? But again, the purpose of our ANCOVA designs is to increase the power of our experimental designs, right? If I'm going through and randomizing people to different conditions, what I want to do is I think about that error term, right? That contains all that within subjects or that within group variability. That could be from due to random stuff, or it could be systematic stuff that we just didn't account for in our design. But if we account for it, then we pull that out and we model it, and so it doesn't go into our error term. And if our error term is smaller, that makes all our F tests bigger, right? And so it goes through and increases our overall power. Okay, so our covariates, in a traditional sense of ANCOVA, is intended to remove nuisance variance from our model that can be attributable to some continuous covariate. Okay, so I've gone through and I've randomized people to different conditions, right? But I'm thinking about like, hey, here are a handful of things that aren't relevant to my project, but I think they might be associated with my outcome. So what I'm going to do is I'm just going to measure those things. And that way, any variability that's due to these things isn't due to just isn't getting included. My model is just random error. So it's going to make that error term smaller, and it's give me a more powerful design. Okay. So as a conceptual, and this is pulling just from this Miller and Chapman paper. Okay. So they pose this question: does vehicle size, small, medium, or large, impact driving performance? Okay. And the hypothesis here is that smaller vehicles are going to be associated with increased performance. Like if people are driving smaller cars, they're going to do a better job with things. Okay. So if we go through and we take a look at this, and so what I go through and I randomize people to small, medium, and large, sort of have a track, small car, medium car, large car, have them go through, drive around, and I measure their performance, right? And so here's average performance for the set, let's say, okay? Or here's average performance for the large vehicles. So large vehicles performance, here we go. Medium vehicle performance increases a little bit. We take the average, right? Thinking, okay. Large vehicle, or excuse me, small vehicle performance at its highest level. Okay. And so if we're going through and we're just taking a look at this, we're saying, okay, we are seeing evidence for my hypotheses that as my car size decreases, performance increases, right? So we're looking at some mean level differences. And so if we were to plot these out, this is kind of what we might get like, right? So performance greater is in my small car, medium car, and then here's my large car here at the bottom. We're kind of following the example. So here, my ANOVA is calculating error as a deviation from the group mean. Any deviation from a group mean is our within group variance, right? So if the only thing that determines people's driving performance is what size of car that they're driving, then everybody's performance should be identical, right? But it's not. We're seeing differences here for my small cars, here for my medium cars, and here for my large cars. Anything that's included in that is just straight up error. It's not something that's recognized as systematic in my model. And so if I just run with this with an ANOVA, I'm gonna get a lot of within group error within this, right? Because there's a lot of variability in terms of performance, okay? And here we can see this now as we pop up those error bars, we're seeing a great deal of variability within each one of these groups. Okay. But let's say we go through and ask ourselves, does vehicle size, small, medium, and large impact driving performance once we control for driver experience? Okay. Now, before what we did is the first scenario, we just ran our ANOVA, right? We had a big track, we brought people in, randomized them to small, medium, and large cars, and we kind of found about what we would expect. But we've got a lot of variability here. If these are confidence bounds, there's a lot of overlap. I might not have, unless I have a whole bunch of people, it might be hard to kind of, the pattern is looking good, but I might have a hard time actually getting evidence for that effect that I'm looking at, right? But what I might say is like, boy, probably these people that I'm randomizing to different vehicle size groups, they probably are coming in with different levels of driving experience. Maybe that's something I want to control for in my experimental study to make sure that that to at least account for this outcome, because I can imagine that driving experience is going to be related to performance. My assumption is that people with more driving experience are going to be better at performing things than people with less driving experience. That makes some sense. My study isn't actually really interested in driving experience, but it's a factor that may impact my outcome that I might want to account for to help sort of reduce some of the error in my experimental design. So if I go through and I say, okay, I'm going to model experience down here, right? And I'm going to have a regression line where I've got the relation between experience and performance for my large group, for my medium group, and for my small group, okay? Again, these are just folks coming in off the street that I'm randomly assigned to run this performance track, but I'm also going to go through and measure their experience. And so what I've got is a linear relation between experience and performance. As experience increases, performance also increases. Okay. This is what we're doing with ANCOVA. ANCOVA is going to regress a dependent variable onto my covariate, and then look at differences in my adjusted mean, calculated as the expected value of each group to the mean of the at the mean of my covariate here. So here, let's say this is average experience for this sample. Okay, so this is for everybody. Here's the average experience level. Now what I'm going to do is I'm going to compare. Here is for my small car group at average experience. This is what I would expect them to perform at, right? For my medium car group at average performance, this is where I would expect them to perform at. Here at my large car group at average performance, this is where I expect them to fall at, right? So now what I've got is I'm looking at the difference between here and here and here, right? Now, these aren't actually values that exist for anybody in the sample. They're the adjusted mean. But once I regress my dependent variable, my performance variable on my experience variable, I'm basically running a regression line and saying at average, these are the means that I'm comparing across. Okay. And what we're doing here is we're calculating my error as the deviation of scores from my within group regression line. Okay, so now instead of here, where my variability is the difference of each person from the mean of that group, right? So here I've got a lot of differences all across these groups. For my median group, a lot of differences, here a lot of differences, right? With my ANCOVA, as soon as I model experience, right, I'm looking at mean differences at the average level across my group projected, but then my error is calculated as the deviation of my group from its regression mean, or from the regression line. So now my errors are just the difference between my observed values and my regression line, as opposed to the mean of the whole group, okay? And so what that's gonna do is it's gonna reduce my error. My error is gonna be much, much smaller for that, because it's the error that I expect after controlling for experience in this example. Okay. So again, primary function of ANCOVA is to reduce that error term in my overall ANOVA. Okay, and what we do is we change how we're calculating the mean difference. Now we have differences projected at the average level of my covariate or covariates, and then my error term is the difference between my expected point on the regression line for my covariates and my actual observed, as opposed to the difference between the group level mean. Okay, so what this does again is it just shrinks down that error term by a ton, if done correctly. Okay. Now, unfortunately, in practice, and this is sort of us clinical folks and sort of other sort of groups of people, what we have often tried to do is try to use ANCOVA to control for some pre-existing difference on some covariate. Okay. ANCOVA traditionally is an experimental technique. I'm going through and I'm randomizing people to different conditions, and I'm just measuring this other stuff that I think is going to be related to my outcome, but has nothing to do with the randomization, right? What folks in clinical and some other people said, like, oh, hey, what I'm going to do is I'm just going to go through and I want to look at differences across these groups, but I'm going to control for this stuff to try and make everybody equal, okay? So if you think about going back to our driving performance situation here in our randomized experimental condition, here's the relation between performance and driving experience and performance for people I randomized to small, medium, and large cars, right? And here's the mean comparisons that we're going to make. These are our adjusted means, right? This is my experimental design, right? But if I just go pull people off the street and I say, hey, you got a big truck. Hey, you've got a small car. Hey, you've got a medium car. Come jump on my track and drive around and go through and take a look at stuff. But hey, we're just having people come in who aren't randomized. These are just folks who are existing out in the universe. What I'm going to do now is I'm going to go through and I'm going to control for performance here. Well, now all of a sudden, or experience. Now all of a sudden, here's my mean experience, right, for the whole sample. But remember, with ANCOVA, what's happening is I'm going through and I'm looking at the expected difference or the expected outcome for my group at the average level of my covariate, right? So here, maybe all the people who are driving big trucks have lots of experience, and that's why they got bigger vehicles, because they're feeling more experienced and more comfortable with them. People with my tiny cars are driving tiny cars because they're high schoolers, and that's what you can afford when you're in high school. Who had a tiny car in high school? They have yeah, what do you have?
Ford Fiesta.
A Fiesta, nice, nice. I like the Fiesta. I had a buddy at Geostorm, right? We have to sort of drive down Sugar Beats on the road. Wreck his wagon wheel car, right? But maybe here you got people who with smaller cars just don't have as much driving experience, right? But now if we're going through and we're comparing in this ANCOVA, and I'm going to go through and I'm going to control for driving experience, what it's done is completely distorted of this, right? Because my expected performance for people who are driving large cars at average experience is way down here, right? Versus the expected performance for people with medium cars at average experience is here, and small cars is here. What it is completely distorted, completely wrecked sort of a reasonable comparison. So my comparison now is between this and this and this, even though for my people who are driving big cars, the expected value at average experience is not anything that's even a realistic value for that anybody even sort of showed in there. Same thing for my small cars. Average driving experience for the full sample is way above, exceeds any actual performance that we actually saw in that group, right? And so what we've got with these adjusted means is a crazy distortion of sort of what's going on. And so I'm gonna say, oh, hey, I found differences here, when in fact, these are the average differences, right? Here's the mean of this group, mean of this group, mean of this group. But these are the means that we're comparing at. Makes it really different, distorted. And what's happened is we've gone through and we've got a confounding between my covariate and my grouping variable. My grouping variable is what cars are people are driving, and I've tried to control for experience. But experiences is intricately sort of involved and part of what makes those groups different. And so when I do that, it screws everything up. Okay. So our analysis here is looking and wanting to look at and guess what means would have been had the target groups not differed in sort of whatever the thing it is that they're looking at, right? For our first example here, when we go through and randomize everything, all we've done is removed variance for the error term that's attributable to driving experience. I've gone through and randomized people, so all I'm doing is pulling the driving experience out of that. And all I've done, my means are all about the same. I've just sort of reduced that error term. My second example, I'm reducing the error term, but I'm also adjusting the means to the point where the means don't actually correspond with anything that we've actually seen in this data. Okay. And the core issue is I'm saying, how would people who drive big cars and different little cars differ in driving experience or different in performance if they didn't differ in driving experience? Well, they do differ in driving experience. That's why they're driving different cars, right? So it's a nonsensical question, or it can result in a nonsensical question when we're going through and we're sort of taking this out of the realm of experimental stuff and dropping it into pre-existing groups. So Miller and Chapman talk about appropriate use for ANCOVA within the context of a randomized experimental design, okay? My expected value of my covariate is going to be equal across groups, right? If I just randomize all people and add 2 small, medium, and large cars, I don't expect average driving experience to differ across these groups because I've randomized them. So I'm in pretty good shape here, right? In the absence of grouping effect, no difference is expected across my adjusted means because it's all going to be the same for everybody, right? All we're doing is reducing the error term. More problematic is for use in a randomized design where the covariate is assessed after. Should I apply whatever treatment it is? So I'm asking people to self-report experience, and I only ask them that after they've gone through and driven my course. It's possible that their performance actually impacted their perceptions of experience and things along those lines. Here, the people in the small cars will be like, oh yeah, no, that was easy to go through. I was able to go. Does anybody ride motorcycles?
Yes.
Yes.
Like,
Driven one or
What's
rode
that?
on someone with
feel-
someone?
yeah, what do you mean?
Well, so the thing is like, so I have my motorcycle license, but sort of one of the things that they'll tell you before you take that road test is don't necessarily you ride it on the bike that you, if you've got a big old bike, because there's a lot of things like you have to accelerate, stop, sort of make turns and stuff like that. If you just got a giant sort of massive hog that you're trying to get, like it's hard to go through and do that. If you've got like a little scooter thing like that, it's really easy to do that, right? And so if I'm on a tiny scooter taking that motorcycle course on a little tiny motorcycle, it's going to be easy. I'm going to feel pretty good about my sort of performance. If I just tipped myself over and crashed and made a jerk of myself trying to get this done, like I might have concerns about whether or not I'm actually good at doing this thing, right? And so here, what I might expect is for people who use the small motorcycle to run their tests, may have much higher perceptions of their overall experience than people who didn't, right? Or who ran with a larger vehicle, okay? So essentially, if we're saying, we're asking in this situation, what our groups would look like if they hadn't differed on a covariate. when differences in the covariate might be part of what happened when I actually assigned that treatment, right? Most problematic is when we use pre-existing groups, which is what we almost always do in clinical stuff, because we can't randomly assign people to ADHD or alcohol use or sort of any other such thing, right? With our pre-existing groups, there's no basis for assuming chance differences in the covariate, particularly if I've specifically selected a covariate that in part defines what my grouping variable is, right? I said this happens in my area, like, oh, I'm going to look at differences between sort of people with trauma and without trauma after or with PTSD and without PTSD controlling for depression. It doesn't make any goddamn sense to ask what people with PTSD, how people with PTSD are different than people with depression, or than people with PTSD without PTSD if they didn't differ on depression scores, like say PTSD, because they do. They're for sure going to differ. So asking what they would look like if they didn't is not a useful question to ask, right? And so again, just a couple of quotes that I like. One may well wonder exactly what it means to ask what the data would be like if they weren't what they are. I think, boy, it'd be awesome. Like, what would this look like if it wasn't this, right? Like, well, I don't know. That's a scientific question. Tabachik and Bell, adjusted means should be interpreted with caution, given that adjusted dependent variable score may not correspond to any situation in the real world, right? So being very, very careful when you're going through and using these analyses. So assumptions of ANCOVA, normality of sampling distributions, that's sort of not anything that's new. Don't want to have outliers, don't want to have collinearity. Linearity starts to become important, making sure that you have a linear relation between your dependent variables and your covariates, between pairs of covariates. Basically, this is a blending of regression and sort of ANOVA stuff here, okay? Homogeneity of variance, both to your DV and your covariate, and then you sort of want to have sort of relatively equal sample sizes. If you start to deviate from this, things start to get problematic. Okay. New business with ANCOVA stuff like that, we have a homogeneity of regression assumption. What this is saying is that what we're assuming is that you have an equal association between my covariate and my dependent variable across my different groups. If I have an interaction of my grouping variable and my covariate, then ANCOVA is problematic. Okay, so in this situation, here I'm looking at differences in west, south, and north, right? And I'm looking at, so this is my outcome, and this is my covariate. I'm seeing that my covariate and my outcome have equal associations across all of my groups. If this is the case, then I'm in good shape. I've met my assumption of homogeneity of regression. In this situation, not so much. For this group, I have a strong association between my covariate and my outcome. For this group, I have next to no relation between my covariate and my outcome. And so in this situation, this would be a violation of my basic assumptions of ANCOVA. And so this would be a problem. Now, what do we do with this when this happens? I don't know. I've gone down several wormholes trying to figure this out when it's come up in things. It's kind of a complicated thing. I don't know that there's a good answer, right? But hopefully, if used appropriately in the context of experimental designs, right, Jim, you're running a thesis, you've got people randomized in different conditions, and you're looking at something having to do with perceptions of guilt or something like that. You might say, hey, here's some things that I think might impact perceptions of guilt. I don't expect those to differ across my groups necessarily because I randomized people to them, but it's something that could account for variability in my outcome. So I'm going to go through and measure that, include that as a covariate just to go through and reduce my error term. That's fantastic. That's a smart use of ANCOVA, right? Instead, what we generally do is like, oh, I want to look at sort of these different groups, but I want to control for this other thing. And if that other thing that you're controlling for is a thing that very much makes those groups different, that's actually a problem, right? I want to partial out a thing that makes these groups different. starts to come into a circular nonsensical question. What you often see, at least in clinical literature, is people will go through, hey, we went through and looked at people if they're different on all these different things. And then if they were, then we went through and controlled for it. It's a bastardization of the whole thing, and actually is kind of problematic. Particularly if that thing that you're looking at is something that actually defines those different groups. Yeah, Lindsay.
I was wondering, like, if in the population, you know that there's not an actual difference between the groups, would that then justify controlling for those differences?
It kind of depends. It kind of what the and sort of when you go through, and the reason I want to go through and hit this is just to provide some context as you're going through and reading that Miller and Chapman. Make sure to go through and read that Miller and Chapman piece of things. That'll be. So look at that, right? The problem is what you would want to do is, like, let's say Mesa wants to look at differences in sort of folks with ADHD, kids with ADHD and not, but controlling for behavioral referrals. Well, behavioral referrals are part of what causes problems in folks, kids with ADHD. Like, so why would you control for that thing? Like that doesn't make some sense. But in your data, if it's just like, hey, this is something that was, and it's not necessarily if it's not a piece of what you're actually trying to look at, then that's probably fine, right? Where people start to get into problems is just indiscriminately like starting to throw things in as covariates, and then things start to get problematic. A lot of what happens in clinical stuff, like, oh, I'm going to control for negative affectivity or neuroticism. Well, then, like, you just like are asking, like, what are my clinical and non-clinical groups? If I say that they're equal on negative affectivity, then I don't know how these are different anymore. They're not the groups that I'm actually interested in, right? So not saying that sort of that you couldn't ever do this. So just the resources are saying you just have to be very, very careful and think about what the consequences of this are, right? So appropriate application and interpretation, Miller and Chapman, one of like this is just an incredible article, which is very good. Howell is good, Tabach Dell. They say primary use of ANCOVA is to adjust group means to what they would be as if all subjects scored identically on the covariates. Based on Miller and Chapman, I would be very concerned about that, right? Because like, hey, how would these groups differ if they were all the same on this thing? But they're not all the same on this thing. If they're not, then we start to get into a weird question about whether or not, I mean, SPSS will give me an answer. I just don't know if it means anything useful. All right. Other stuff in this slide deck has to do with ANOVA. We're not going to cover ANOVA. If you're interested in ANOVA, I would refer you to Tabach and Fidel. Anybody use ANOVA to do some ANOVA stuff? Take a dump on ANOVA, right? I mean, it's just what it ends up being is another omnibus test that if you find an effect, you have to go through and then break apart, right? So people have gotten to a point where you start to question whether or not it's giving you anything. There are benefits if you've got a set of outcomes that have modest correlation. You can increase power with that. If they're too correlated, not so much. If they're not correlated enough, not so much. But if they kind of hit that sweet spot. But these days with statistical programs and things like that, what people will often do if you have a question about sort of a combination of variables that all kind of get at the same thing, people will start much more starting to move into latent variable modeling and that type of stuff as a way. If I've got all these things that represent well-being, before I had access to latent variable programming and stuff like that, I would just look at the combination of these things as kind of a representation of well-being. And then if I found an effect, would then look individually at each one of those things. Now, if all these measures are all tied into well-being, then just model well-being as a latent variable and stuff. So, but yeah, these slides just kind of go through that. We won't spend time doing that in here, but yeah, if you're interested, go through, take a look. Tabach and Fidel is a good or a good sort of primer on that. All right, awesome. See. Aren't you so glad you sort of waited for the candy next week as opposed to this week? Because now we've got a wide open class period. So we'll think about what to do for next week. We've covered everything that we need to cover. What we can do now, Kate and Allison will be gone. But what we can do is maybe sort of use that as just a time to either get caught up, sort of work in, sort of bring in, if you want to bring stuff in, I'll hang out, sort of add, and go through and answer questions and stuff like that. I'll take a look, may have some final wrap up stuff to do at the start of class, but then kind of take things from there. But we've gone through, we've covered everything. We've never covered everything, all of our material with a whole class period to spare. So this is kind of a monumental event right now. I mean, I skinnied some stuff up, so I didn't throw everything at you. So I'm trying to be judicious in winnowing some things down, but I think we're in a really good spot. Okay, so go through, keep working on this last set. Come find me if you have questions, and we'll get this stuff wrapped up. Okay, awesome.